Hey Year 11s, let's take up Assessment 2, which is based on laws of indices, changing the subject, expanding brackets, factorizing expressions, volumes of cylinders, and bounds of accuracy. This first question is a laws of indices question, where we've got the same base, where y is the base in all of these terms, and we've got some multiplication and we've got some division. Remember that when we're multiplying two terms together, if they've got the same base, we're adding the indices, so that's 3 plus n. And when we're dividing two terms with the same base, we're subtracting the indices. So I've got 3n minus 1. Now this can be simplified. I can group my like terms together. That is, I can use the calculations involving the numbers, not the n. 3 minus the 1 is 2. So I've got 2 plus n. Now, since I've got the same base, and I'm really trying to work out what the index is, I can just ignore the bases. Y to the power of 2 plus n is equal to y to the power of 6. That must mean that 2 plus n is equal to 6. So just comparing the indices, I can say 2 plus n is 6, and I now have a much simpler equation to solve. I just need to get the n on its own. So n is equal to 6 minus 2, because opposite of plus is minus. I've moved it across. And n is equal to 4. So there's my answer, n equals 4. This question is also laws of indices question, but this time I've got y to the power of 2 in brackets, and I've got a second power outside. I call this the power of a power rule. And when we've got the power of a power, what that means is I've got y to the power of 2 multiplied by itself 8 times. If I use the multiplication law, I would be adding 2 plus 2 plus 2 plus 2 8 times. But much more simple, the law of a power is that we just multiply those numbers together. So this is going to be y to the power of 2 times 8. And 2 times 8 is 16. And once again, if I've got y to the power of something is equal to y to the power of something else, I can just compare the indices because I've got the same base. I'll say that the indices must be the same. 16 must be equal to n, or n is equal to 16. Next, another laws of indices question, and this one's pretty straightforward. The only thing we have here is a division. We've got all the same bases. E to the power of 9 divided by e to the power of 5 is e to the power of n. So simplifying these terms, when you've got the same base and we're dividing, our indices get subtracted. So I've got e to the power of 9 minus 5. Now 9 minus 5 is 4. So e to the power of 4 equals e to the power of n. And again, I've got the same base, so let's just compare the indices. 4 must be equal to n, so n must be equal to 4. Now, changing the subject. This one's a little bit more challenging. Usually you would have to show all of your algebraic working and work out the answer for yourself. And I hope you all did that, because I gave you these multiple choice questions here, but they're all quite similar. They all have n's and t's and 3's and square roots and squares. So don't just randomly choose, don't just guess. Make sure that you can work it out for yourself. And when your answer matches one of the answers over here, you'll know that you're right. So let's get started with this. The first thing we need to do to liberate the n's, we don't want these n's in fractions, we don't want these n's under square root signs, we want the n by itself and everything else to the other side of the equation. So to get rid of the square root sign first, the opposite of square rooting is squaring, so I'll do t squared is equal to n plus 3 over n. So this side is all the same except for I've gotten rid of the square root sign. Now I want to get rid of that fraction. I hate working with fractions. The easiest way to get rid of them is to move the denominator to the other side. The denominator is dividing, so when I move it to the other side, it will be multiplying. So I'm going to take that n to the other side, and I'll have nt squared is equal to n plus 3. See how I easily got rid of that fraction in one easy step, moving the denominator to the other side and multiplying. Now I want to get n on its own. And that's going to be difficult because I've got an n term here and an n term there. So let's get them together on the same side. I'm going to move this n over to this side. It was plus n, now it's going to be minus. So I've got nt squared minus n is equal to, the 3 is now on its own on the other side. But I want the n on its own, and it's in these two terms. Usually what I would try to do is group these terms together to get some number of n and then just move the number to the other side. But in this case, I can't group these two terms together. What I can do is see that they have a common factor, which is the n. So I'll factor the n out. and then I'll try and get the n on its own. Here I factored out the n, and you can see that I've done that correctly because if I did n times t squared, that would be nt squared. If I did n times minus 1, that would be minus 1n. Okay? The reason I did that is because now I have a single n out front, and I can move the bracket to the other side, leaving the n by itself. So remember that n is multiplying by the bracket. I'm going to leave n by itself, and I'm going to take the bracket to the other side and divide. So there's my answer. N is by itself, and it's equal to 3 over t squared minus 1. Look over here, see if you find your answer, and I see it here, and that makes me very happy. Next question, again a change in the subject question. And once again, just to make this easy for you so you didn't have to type in answers like these, I've given you multiple choice, but you must show algebraic working. You must be able to do it on your own. Do not guess. So I set up my equation here, and I'm trying to make g the subject this time. Again, I've got two terms with g in them. So I'll group those two terms together and see if I can get g on its own. So I started by taking this 9eg over to this side. It was plus, so now it's minus. And in the same step, because I want to get g on its own on this side, I took the e from this side, the 3e, and I minused it over to here. Because it was plus there, it's minus here. So I want to get g on its own, and just like the previous example, that means getting the g away from both of these terms. I can't group these terms together because of that ugly looking e over there, right? But what I can do is see that there's a common factor, which is g. I can factor it out, and that's one way of getting g on its own. So factoring out the g, you can see I've done that correctly because if I were to do g times 4, that would be 4g. If I were to do g times 9e, that would be 9eg. So I've got that correctly outside. I want the g on its own. I can easily get rid of this bracket. The bracket is multiplying with the g, so I'll take the bracket to the other side and I'll divide. So I get g is equal to what we had there first, the 7 minus 3e, divided by everything that was in the bracket that's come across is now divide. Okay, let's look for the answer over here. There I see it, 7 minus 3e over 4 minus 9e. And that makes me very happy as well. Next, we're expanding brackets, and this should be pretty straightforward for you. That's just multiplying this out. So I'll do x times the x, which makes x squared, x times the minus 2, which makes minus 2x, 9 times the x, which makes 9x, and 9 times the minus 2 makes minus 18. The trickiest part of this is to make sure you've got the right signs. I've got positive x squared because I did positive x times positive x. I've got negative 2x because I did positive times negative 2x. And then I have positive 9x because I had positive 9 times positive x. And I have negative 18 because I did positive 9 times negative 2. Okay, now I can group my like terms, my middle two terms, minus 2x plus 9x. The 9 is bigger than the 2, so that's going to end up being a positive answer. That's positive 7x. So I've still got x squared, same as above. I still have minus 18, same as above. And my middle term groups together to make positive 7x. There are lots of different options there that it could have been, so I didn't want you guessing at this. It looks like it could be this one, but that's a positive 18. I think it's this one. Yes. Okay. Factorizing. Once again, I'm saving you from having to write this, but you need to be able to factorize for yourself and factorize fully. So looking at this expression, I put it in different colors for you so you can see what the common factors are. Comparing the numbers, you should be thinking, what number could we divide both 16 and 20 by? Looking at like c's, I had c to the power of 4 here, but here I only have c. So what power of c could I divide both of these by? And the same thing with the p's. I've got p to the power of 2 compared with p to the power of 3. All together, for both of those terms, I could divide them both by 4 because of the 16 and the 20, and c, because this can be divided by c at least 4 times, but this can only be divided by c once, and p squared, because this can be divided by p squared, and that can be divided by even more than just p squared. Right, so that gives me 4cp squared out front. That's my common factor, and I know I've done that right because if I were to multiply this through, I would have 4 times 4 makes this 16, c times c cubed makes c to the power of 4, and I've got my p squared here. So that's the first term. Checking the second term, I do 4 times 5 makes 20. C gives me the C that I need, and p squared times p to the power of 1 would make my p to the power of 3. Now this is not fully simplified, and I didn't want you typing this in and getting mistakes, so that's why I gave you options here to choose from. But fully simplified, I don't need that power of 1 here. So looking for that answer over here, I can factor out more than just 4. I can factor out more than just the letters c and p squared. And here I factored out too high of a power of c to the c and too high of a power of p. It's this one down here. Right, the volume of a cylinder and bounds of accuracy. Here we're talking about a cylinder with a diameter of 14 centimeters and a height of 20 centimeters. Both of those values, though, are not perfectly accurate. They're correct to the nearest centimeter. So working out the lower bound of the height of the cylinder, the height was 20. So the lower bound of the height to the nearest centimeter, it was 20 centimeters. It would have been between 19 and 20. What's the value between 19 and 20? That's the boundary that decides will we round to 19 or 20. Right in between them is 19.5. That's our lower bound for the height. And the lower bound for the radius, be careful on this one because we are told the diameter. If the diameter is 14 centimeters to the nearest centimeter, so they rounded that, they measured it as accurately as they could to the nearest centimeter. It could have been anywhere between 13 and 14. But what's the lowest it could possibly be? Lower than that, it would have rounded down to 13, but it rounded to 14. The lower bound is 13.5. Be careful though, don't put that as your answer because that's the diameter. The radius is half of a diameter, which means that the lower bound for the radius must be 13.5 divided by 2, which is 6.75 centimeters. So our answer for the part B is 6.75 centimeters. That's our lower bound radius. Now, having worked out these two values, you're meant to be using these two values to work out the lower bound for the volume of the cylinder. We know the formula for the volume of a cylinder. It's pi r squared times h. That's the area of the circular cross-section multiplied by the length of the prism, right? Now, knowing that the radius or the lower bound for the radius is 6.75, we'll substitute that in. And knowing that the height is 19.5 or the lower bound for the height is 19.5, that will give us the lower bound for the volume of the cylinder. So the lower bound for the volume of the cylinder is pi times r, which is 6.75, squared times by the height, which is 19.5. Working that through, that gives you approximately this amount. See that I've had to round that because whenever I multiply by pi, I get an irrational answer. And I'm asked to round to 3 significant figures. So don't put all of those digits, 3 significant figures, 3 non-zero digits, 2, 7, 9 with a 1 after it is going to stay a 9. 279, and I need the 0, otherwise 279 is way smaller than the actual volume of the cylinder. The 0 is just a placeholder, it's not significant. So our answer is 279 centimeters cubed. Now, well done on this first assessment, but let's keep going to make sure that we make our dream assessment a true dream come true.